So I know that when you get a pet, one of the first things you want to do is give it a name, come up with a great name for it. Well, we do the same with triangles. They're not pets, but we give them names and we give parts of the triangle particular names. We're going to spend a few minutes talking about how we name these triangles or the parts of them. Now, we are looking at two right-angled triangles. I know they're right-angled because of the little square box in the bottom corner here that indicates a 90-degree angle, making them right-angled triangles. Now, the one on the left, let's deal with that first. If I was to go through and put some letters at each corner, I've called it A, B, and C. Well, guess what? The name of this triangle, and here's how I write it. I write triangle ABC. Okay, every point, there are 3 points, and we give them a certain name, which we'll talk about in a moment. I'm going to put a letter at, and that is the name of the triangle. Now, you might look at that and go, well, hang on, how come I've got to start here? Well, guess what? Yes, it could have another name. I could call it maybe triangle BCA because it goes BCA. They're still the 3 letters at each corner. And I guess I could call it CBA or CAB as well. So there's a number of different names so long as you're using the 3 letters at each corner. And we indicate that by a little triangle symbol at the start to say, hey, we're talking about triangle BCA. Now, the pointy bits are actually called a vertex. Each one of these is called a vertex. The plural is vertices. The pointy bit of a triangle is called the vertex. So with triangles, we always use capital letters to represent a vertex. You'll see this is a capital A, B, and C. But on the sides, we use little letters, and we use the letter that is the opposite vertex. So if I look here, this side is on the opposite side of the triangle to vertex A. So instead of a capital A, I give this little a to represent the relationship that these are opposite to each other. And it's the same for every other corner. Capital C vertex has a little c on the opposite side. Capital B vertex has a little b on the other side. So this is side C. And you'll see that we use lowercase letters for the sides, and they are opposite each other. Okay, let's move over to the right-hand side, because now we're going to move away from naming them with letters and talk about some of the parts of a triangle. Now, hopefully, you can remember from some previous work on Pythagoras that a right-angled triangle has one side that's always the longest, and it's always the one that's on the opposite side of the right angle, and we give it a special name. We call it a hypotenuse. So I'm going to label that with the capital H just to represent hypotenuse. Now, I know that kind of goes against what I just said about using little letters on the sides, but I'm sorry for this. This is kind of different. We're not naming the triangle here. We're just talking about the parts of it. So if this side is the hypotenuse on a right-angled triangle, what do I call these sides? Do these have a particular name as well, or a particular feature of them? Well, they do, but it kind of depends on one important thing. It depends on an angle. And in a question in trigonometry, if I'm given an angle or a symbol to represent this is the starting point, or this is the angle I'm using as my reference point, excuse me, and angles are usually represented by Greek letters, in this case the letter theta. Now I've got this angle which indicates I need to start here, and if I start at that angle and I go across to the side that is on the opposite side of the triangle, I call it the opposite because that's what it is. It's the side that is on the opposite side to my angle. Okay, now I'm given an angle. It might be a number or it might be a symbol. That's okay. That means that is the one that we're going to use as our starting point. And I can see as I go across, this is my opposite. So I'm going to mark that with an O. What does that leave me with? It leaves me with this side here, the one that's touching the angle. It's next to the angle. And another word for next to is adjacent. If you're sitting next to someone, you are adjacent to them. So this side is next to the angle. Okay, so we call it the adjacent and we mark it A. So we have a hypotenuse, an opposite, and an adjacent. And these are really important as we start to get into trigonometry to identify which one is which. Now, hopefully you'll see that they could change. The O and the A could change, because what if my angle was up here instead? Well, the hypotenuse doesn't change. You'll see it's the same. It never changes. It's always opposite the right angle. But now that I've got an angle up here, well, this side now is the one that is opposite my angle. It's on the opposite side of the triangle to my angle. It doesn't touch my angle. The one that next to it, touching it, is the adjacent. So it really depends on my angle of reference that I'm given as to which one is my opposite or my adjacent. Now there's a fair bit in that, guys, so don't feel, don't forget. You can pause it, go back, revisit a few pieces. But when we get into trigonometry, this stuff here is going to be really important to identify hypotenuse, opposite, and adjacent. Well done.